Now, continuing from the previous video where my focus was on measures of central tendency, I am going to continue my discussion on measures of dispersion. And if you notice as well, let me scroll down to the end. If you notice, I have actually added some other components. Initially, it was mean, mode, median, and standard deviation. I have, however, added variance and skewness. I'm going to be showing you guys how to do that in Excel and also how to interpret it. Now, the calculating the variance is pretty simple, as with the other measures that we have done. In the cell, you simply select equals and you go to statistics, more functions, select a category. It's already set to statistical, and I can just let me scroll down for variance, and you're gonna see three variances. The main ones are the variance of the population, the variance of the sample. I'm going to select variance for the population since I'm dealing with all the countries of Latin America and the Caribbean and not a subset of those countries. Now, if I was dealing with a subset of countries in Latin America and the Caribbean and I wanted to generalize to my population, I would select the second option, which is the sample variance. But for now, I'm working with the population variance. Now, in the same way, I'm gonna have to select my range, and I want the variance for the values ranging between B4 and B45. Those are that cell B4, and it actually goes all the way down to B45. I'm going to click OK, and there I have it. I have my variance for that group. Now let's work out the variance for this group, which is the population growth rate for 2015 to 2020. The variance here would be the same way, equals, and I'm gonna do it a different way. I'm just gonna type var p, which is the variance for my population, double click and select, I'm gonna select my data range, and it goes from, in this case, C4 to C45 being here. And I'm going to close my bracket, enter. Right? So that's the variance. But the variance is not very easy to interpret. It's not really interpretable, because it is actually the square of the standard deviation. It's expressed in the unit of the data, but because the units are squared, it's actually harder to interpret them in relation to the values in your original data set. And to compensate for the deficiencies in interpretation for a measure like the variance, the standard deviation has been developed. Now, the standard deviation is really a measure of dispersion, or you can look at it as the amount of variation that exists within your data set as it relates to the mean or the average value. So you're kind of looking at how the values in your data set are distributed in relation to the mean. And you're really looking at the average distribution in relation to the mean. So is the data more scattered? Are the values in the data set closer to the mean? Do they cluster around the mean, or are they far apart? Are some values very high and some values very low? Now, a low standard deviation indicates that data points are generally closer to the mean, and higher standard deviations indicate that data points are spread out. Now, because the difference is in units, it is not so easy to compare two standard deviations. So, for example, it would make a little sense for me to compare the standard deviation for the value that I would get for the standard deviation of height, for example, in a class, versus the speed traveled by a motor vehicle or something like that. So it's very hard to compare on that basis, but I can, however, compare the standard deviation for a group for class A, for example, for student in one class versus student in another class, I could compare the standard deviation of heights. So I'm going to get into standard deviation, and working out the standard deviation, I will do this, and I'm working it out for my population as well, again, because I'm dealing with all the countries in Latin America and the Caribbean, so that's a population. So equal, and as soon as I start typing the shortening for it is STDEV, but it will pop up as soon as you type STD. So STDEV dot P, that's just population, standard deviation for the population. And I'm gonna click, and I'm gonna use my B4 to B45 to select my range, and then I'm gonna click enter. I'm gonna do the same thing here, STD, select standard deviation for population, double click, and I'm gonna click C4 to C45, right? Enter, right? So my standard deviation for the first group, which is the 2010 to 2015 population growth rate, for countries in Latin America and the Caribbean, is higher than the standard deviation for 2015 to 2020. And this might actually suggest that that the disparities between the population growth rates for individual countries is actually declining, that the disparity is going down. And of course, as countries get more and more developed, it is possible that these differences will actually become smaller, or it is likely that these differences in growth rates will actually become smaller, because population growth rate, as you know, is a proxy for development, is an indicator of development. It suggests things like access to contraceptives and lifestyle transitions in the population. So of course, as the world theoretically becomes more and more developed, we would expect a lot of these differences to reduce, and so you'd have greater clustering around a mean rather than a significant dispersion that you would have probably observed maybe a few years ago. Now, skewness is an interesting statistic, because skewness actually looks at the distribution of the values as it relates to a normal curve. And I'm gonna work out my skewness values here. You've already learned about skewness, but I'm gonna show you how to interpret the skewness values. Now, to work out skewness, you skew, and then you'd simply double click, and then of course it would be the same thing, B4 to B45, and then I would click enter, and that's my skewness value of 0.08. And the same thing, skewness here, skewness, skew C4, C45, enter. And of course, the skewness here is suggesting in both cases that I have a positive skew. Now, how do you interpret skewness? If your skewness value is 0, it means that there is no skew in the distribution, and this distribution is perfectly normal. It is a perfectly normal distribution, total symmetry. Now, that is rarely the case, and quite often we use skewness values that are within, even if it gets to 0.1, we still assume that it is adequately normal for the purposes of statistical testing that would require the data to be distributed normally. So even 0.1, 0.2 is fine for skewness, and because it does approach a kind of normal distribution. When you have your skewness approaching 1 now, for a positive skew, or -1 for a negative skew, then you are in a little bit of trouble as it relates to skewness. It suggests that the data is highly skewed. And of course, if it is over 1, it is extremely highly skewed. Now, you can also get a negative value here and here, and if that value is negative, it suggests that the data is negatively skewed. Now, that is it for this demonstration, and I will continue. Well, since I have some more time left on this, I'll also just squeeze into this part how to calculate the maximum and minimum values. So if I wanted to calculate the maximum